Welcome! Today we're diving into some really cool new research that uses AI to predict dangerous weather, not here on Earth, but 93 million miles away, on the Sun.
So, you might be thinking, a storm on the Sun? Why should I care? Well, it turns out that what happens on the Sun definitely doesn't stay on the Sun.
Let's just cut to the chase. The short answer is, yeah, a powerful enough solar storm could cause chaos for the technology that, runs our entire modern world.
And the stakes here are incredibly high. I mean, this isn't some abstract sci-fi idea. We're talking about real-world problems. Solar storms can mess with the satellites we need for weather forecasts and TV. They can knock out GPS, disrupt communications, and even trigger massive blackouts by frying our power grids.
Okay, so what's causing all this potential mayhem? The main culprit is something we call the solar wind. It's a non-stop stream of charged particles that's constantly flowing out from the sun.
But here's the thing, not all solar wind is the same. There's a slower, gentler version, but the ones we really have to worry about are these high-speed streams, or HSS. And you can see why. They're traveling at insane speeds, up to 800 kilometers a second. These are the real troublemakers. And where do these things come from? They blast out of areas called coronal holes. The best way to picture them is as giant openings in the sun's magnetic field that act like a massive nozzle on a fire hose, just spraying these high-energy particles right out into space. And here, you can see what they actually look like. These huge, dark patches on the sun's surface, those are the coronal holes. And if one of those is pointed at Earth, well, it's basically like staring right down the barrel of a cosmic cannon. So if we know where the danger's coming from, you'd think it would be pretty easy to predict when a storm will hit, right? So why is it so incredibly hard?
Well, the simple answer is that the sun is just a chaotic place. It's unbelievably dynamic. Those coronal holes we just saw, they don't just sit still. They're constantly growing, shrinking, and moving all over the sun's surface. That makes forecasting their impact a huge, huge headache for scientists.
Now here's something that might surprise you. It's a little counterintuitive. You'd probably guess the most dangerous time is when the sun is at its most active, during what's called a solar maximum. But nope, it turns out it's actually during the sun's declining phase, when the solar wind gets way more erratic, that these high-speed streams become the biggest threat. This is where it gets really interesting. To try and crack this prediction problem, scientists have brought in a powerful new tool, a deep learning model that they call SpeedNet. So how in the world do you teach an AI to be a space weather forecaster? I mean, how do you teach it to predict the future of something as wild as the sun? Let's break down how they did it.
The process kicks off with a full image of the sun. Then they basically unwrap it and flatten it out, kind of like a map of the Earth. From there, scientists clean up the image, getting rid of all the visual noise, to really zero in on the most important features, those coronal holes. What's left is a clean, simple map that's perfect for an AI to understand.
And the researchers actually took two different approaches. They trained one version of their AI on these really complex, multi-layered images of the sun you see on the left. But they trained another version on the much simpler black and white maps on the right that only showed the coronal holes. The big question was, which method would work better? More data or more focused data?
Okay, so how does the AI actually learn? You have to build it a brain, and this right here is basically the blueprint for SpeedNet's brain. Now, don't worry about all the crazy details. The gist is, the solar maps go in one end, they get processed through all these layers that work like digital neurons, and a prediction comes out the other end. By feeding it thousands of these maps, it learns to spot the subtle patterns that come before a big solar wind event. All right, so they built the brain, they trained it up. But the big question is, did it actually work? Let's get to the results and see how this AI space weatherman performed. First off, and this is huge, SpeedNet was able to predict the arrival of a high-speed solar wind stream with a 3-day lead time. That 3-day warning is absolutely crucial for giving us time to repair our satellites and power grids. But a warning is only useful if it's accurate, right? So how to do? It got a correlation score of 0.68. Now, a perfect score is 1.0. So think of this like a grade. A 0.68 is really, really good. It means its predictions matched up very closely with what was actually measured out in space. And maybe most importantly for our safety, how good was it at spotting the really dangerous storms? For this, we look at the threat score, and it scored an impressive 0.71.
This number tells us how good the AI is at flagging the high-speed events we need to worry about without crying wolf all the time. That's a really strong performance.
And remember those two different training methods? Well, it turns out the model that was fed the simpler black and white maps actually performed better. It just goes to show a fascinating principle in AI. Sometimes less is more. Giving the AI cleaner, more focused data can lead to a smarter, more accurate result.
All right, let's wrap this up. What does this breakthrough really mean for us here on Earth? How does this all lead to a safer future?
This technology is so much more than just an advanced weather report. It's an early warning system. It's a protective shield that gives us the time we need to safeguard the critical infrastructure our entire world depends on.
And that leaves us with a final, pretty powerful question. If AI can help us predict storms on the sun, what else could it do? From asteroids to other cosmic events, this work is opening up a whole new frontier in using artificial intelligence to protect our planet.